Okay, so this lesson is on factoring polynomials. We've done adding, subtracting, multiplying, dividing. The last thing here that we do it's not the last thing, but the next thing we're going to do with polynomials is this factoring. Now, we did factoring with quadratics, where there was an ABC method, there was completing the square method, there was solving by graphing, or not solving, but there was factoring, there was difference of squares, that was another one. And so this one takes it up a notch and expands it beyond quadratics to anything, any polynomial. And there really is only a couple of things to look at when you're factoring polynomials. Okay, one is this first one, which is factoring by sum or difference of cubes. Okay, there is a formula for sum and difference of cubes, and you will be given the formula on outcome quizzes as well as the test. So as long as you know that it's a difference of cubes, which means that you have some term and it's subtracted, and whatever is here is a cube of something, and whatever here is a cube of something, you can do that. It also works for sums as well. So here and here, if it's something added, and whatever's here is cubed, and whatever here is cubed, this works, and you can use the formula. And all you do is just plug your numbers into the formula, and we'll show you that. The other one's by grouping, which you already know how to do. Remember, grouping is if you have 4 terms, you can group them and then take a GCF out and all that stuff, and that's no different than the grouping the way it was before. The last one is just by simply taking stuff out, like GCF. I know it's not on here, but that's the other way, is by looking for GCFs. So if you don't notice a difference of cubes and there's not 4 terms, you can use GCF to try and factor it. And actually, if it's not a sum or difference of cubes, I would look to see if there's a GCF even before you group. So, for example, so here's your sum and difference formulas. They're right here. So basically, it'll be something to the third, something to the third. Whatever this something is, the A, it's always A plus B, and then you square A, put it here, minus A times B plus B squared. We'll show you how you do all that. Subtraction is the same thing, just with the signs are a little bit different. All right. Let's look at our first example here. Okay, so the first one here. Now I don't have a sum and difference of cubes because there's 3 terms and not 2. And I can't do grouping because there's 3 terms and not 4. So the last thing I want to look for is maybe I can take out a GCF. So by looking at this problem here, I can see that I can take out a 20 and an x. So by taking out 20x and dividing that gives me x squared minus 11x and then plus 30. And so now what I'm left with is something I do know how to factor. Okay, you can factor this. Remember, it's whatever multiplies, let me see if I can get a highlighter here, whatever multiplies to be this number and adds to be this number. So what multiplies to be 30 and adds to be negative 11? Well, if you guessed, let's see, no, geez, I don't even, 6 and 5, wow. Had a little brain fart. If you guessed 6 and 5, 6 times 5 is 30. Well, negative 6 and negative 5 multiplied is 30. And negative 6 and negative 5 is negative 11. So how we did this before, we just remember we wrote our dead cartoon eyes, placed the negative 6 and the negative 5 in, and we just brought this down. And that is factoring a polynomial. One way of doing it. Okay, if we look at this one, okay, it's not a difference of cubes. Okay, I don't have anything that's cubed here. I can't group because it's not 4. So I look to take out a GCF. So it looks like I could take an m out of both of them. And then I'm left with m to the 4th minus 81. Now, what we end up with is something we actually did earlier this semester. This is not a difference of cubes, but it's actually a difference of squares. Remember what you do with the difference of squares? You write your parentheses, one with a plus, one with a minus, and then you just square root each of these. Square root of m to the 4th is m squared, and that goes in the first term. Square root of 81 is 9, and that goes in the second term. And then we bring down the m. Now the only thing that's different about this is you can actually go a step further because you have another difference of squares. So here, this is going to break into its 2 with a plus and a minus. Square root both things. Square root of m squared is m. Square root of 9 is 3. And then everything else comes down. And that would be that factored. Okay? So far, we've done taking out GCF and then factoring. This one was taking out GCF and noticing you have a difference of squares, which we did earlier in the semester. And then doing that ended up having another difference of squares. So we did it again. Now, here's the third problem. Now, here with the third problem, I have a sum or difference of cubes. So the sum of cubes has a formula. Okay, because I have two things here. This is 3 cubed and a cubed, and this is 2 cubed and b cubed. I can use the formula up here. I actually have to go back. Okay, so the formula is a plus b, a squared minus a b plus b squared. And all you're going to do, and this acts as your a, and this is your b. So a and b, so a not to the third, so this is going to be, it's just one of the a's. Remember, 27 is 3 times 3 times 3. That's how you get a, or 3 cubed. So it's just 3 a. Okay, that's so when you have 27a to the third, you have 3a times 3a times 3a. So when it asks for just a, it's just asking for the first one. When it says a squared, it wants 2 of them. Okay, when it wants, so b, the b one is 2b times 2b times 2b. So when it asks for b, it just wants the first one. But if it says b squared, it wants 2 of them. So when I do a, it's just one of them, which is 3a, and b is just one of those, so plus 2b. Then I have this part. A squared means it wants 2 of the a's. So 2 of those, 3a times 3a, is 9a squared. Minus a times b. So I have one of the a's times one of the b's. So 3a times 2b is 6ab. And then finally, b squared is, I need 2 of the b's. So 2b times 2b is 4b squared. And that would be that factored. So you're going to use the formula again. So we'll do another problem like that. But that's the formula to use for sum or difference of cubes. Okay. Number 4. Now number 4 has 4 terms, so you could use grouping, but what you might notice is that you can factor something out first. I can take out 3 t's. So if I take out 3 t's and rewrite this, that's 5t to the third plus 2t to the second minus 5t minus 2. And now I can do grouping with these. Now you take out a GCF. Remember, we're not going to worry about this right now. We'll put it in at the end. So I'm going to do grouping. The GCF for the first one is just t squared. So when I take that out, I'm left with 5t plus, if I can do the plus. There you go. And the second one is just a negative 1. So 5t plus 2. And then remember what we do here, we bring these together. So it's 5, or sorry, that's not right. T squared minus 1, 5t plus 2. Then we can bring this down, t to the third. But once again, you're not done. You actually have this right here, which is the difference of squares. So this can be broken down. Square root, one's plus, one's minus. Square root of t squared is t. Square root of 1 is 1. And then t minus 1. T to the third comes down. This comes down. And that is your answer. These things can get quite complicated. You have to be able to look at the problem and just understand what you can and cannot do. Hey, grouping, you can group. I would look to see a GCF first, and if you can do that and then group, just don't forget that you're not always done. Here at the end, we ended here, but hey, I had another difference of squares that I could take even further. So you always want to look for that kind of stuff. Okay, here, okay, I have a problem that I cannot take a number out. I cannot do grouping, and it's not a sum and difference of squares. But some of these problems look like they're in the form of a quadratic. This looks like a quadratic equation. If I just made this a 2 and this a 1, I have a quadratic. So some of these problems that are in these what we call quadratic form, you can actually just treat them like quadratics. What multiplies to be this and adds to be this? What multiplies to be negative 48 and adds to be negative 13? You can still draw your dead cartoon eyes because your a is 1, but now instead of being just y, it's going to be y squared in both of these. And what multiplies to be negative 48 and add to be negative 13 should have been negative 16 and 3. So negative 16 and positive 3. What you'll notice, again, you have a difference of squares. So this will break down even further. 1 plus, 1 minus, square root of each one. Square root of y squared is y. Square root of 16 is 4. Y, 4. And then bring this down. And last one here is another grouping problem. You will notice that you can take out a 5 in all of these, so I would do that first. And go ahead and try the grouping one for this one on your own, and pause the video and then see how you do on your own. Okay, so here's the completed problem. I took out the 5 over here. rewrote it as p to the third plus p squared minus p and minus 1, because 5 divided by negative 5 is negative 1. I grouped first two, grouped the second two, took the GCF as p squared. That gave me p plus 1. Here I took out a negative 1, which gave me p plus 1, which should work out. They should both be the same. Brought in the GCFs, p squared minus 1. Brought this down, p plus 1. Brought down by 5. Turns out that this is a difference of squares now. So that came down into these. So the plus minus, p plus 1, p minus 1. 5 came down, and the p plus 1. And that is your final solution. Okay. So that's really, I believe, as complicated as you're going to see it. I think, let's see what else we got here. I think that's probably where we are going to stop. Okay. Basically, the last page here is the factor theorem, and we've already done this. This was the last class. So when you want to know if something is a factor or not, so it says, you know, is this right here a factor of this? You have one of two choices. You could factor that and see if x plus 1 is one of them, or use synthetic division and see if you get a remainder of 0. So because this is a dividing by a thing that looks like x plus or minus some number, I can take this and use synthetic division, so opposite of that sign is negative 1, and if I get a remainder of 0, that means that that is a factor. So let's see. So if I draw my line here and I put my coefficients in there, so 1, I don't have an x squared, so that's 0, and then negative 13, and then negative 12, and let's see if I get 0. Let's fill this in. 1 comes down, 1 times negative 1 is negative 1, 0 and negative 1 is negative 1, negative 1 times negative 1 is 1, negative 13 and 1 is negative 12. Negative 12 times negative 1 is positive 12, and you'll see here that when I do this, I get 0, which means that yes, that is a factor. If you were to get a remainder anything other than 0, then it would not be a factor. And that's how you determine whether or not it is a factor. You can do the same thing for 16, the same thing for 17. Just plug in whatever this is. Remember that it is the opposite of that. So it'd be, you'd put 2 here. Oops. You'd put a 2 there. And then fill in all this. Just make sure you don't skip any terms. So 6, 8, negative 34, negative 12. Bring this down. 6 times 2 is 12. 8 and 2 is 20. Times 2 is 40. Negative 34 and 40 is 6. 6 times 2 is 12. And so, yes, we got 0 for a remainder, which means that this is a factor. And that is the rest of the notes. Please, 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 please try to attempt the practice problems that are in there under 4-4. And if you have any questions, you're more than welcome to email me or come into AL on Monday if you have any questions. Remember that by doing the homework assignments correctly, you do get those G-Bucks. So, thanks.